Hi everyone. I think we are live now. Okay. Hi and welcome to this week's webinar, which is about some tips and tricks on Project 2. So we're going to keep this webinar short, and let's jump straight through the notebook. So uh, the the description of the project is pretty self-explanatory. We're importing some packages, and then we are going to see some of the questions that are here. What the approach that I will follow is that I'm not going to address straight the questions, but something similar that it can give you some hints that you can apply to the project itself. So the first question is this one. We have a data frame or a series, doesn't really matter, and we are asked to calculate to get the highs and the lows in a window. Let's see something simpler that I have prepared. So we are importing some packages, and let's say that we have Apple's stock price, and I'm only using 10 values. So waiting for the data frame to load. So let's say we have a very simple series which consists of one stock of Apple. And what we want to do here is to compute the highs and lows in a window. When we see the word window, what happens is that we should straight on think of something that is rolling, so rolling statistics. And we are calling close this data frame. So if we get rolling 3, for example, or rolling any variable that you can use in your project, then we can apply any function, any statistical function that we would like. So let's see here, for example, I'm applying the max value. So what we start from a window of 3 that covers those three values, 3 dates, because the first two values we don't have a window of 3. They return a none value. So we start from the third date, 5 of December, and this is actually the maximum is this value. So we are getting this value. Then we are rolling our window to the next date, and indeed the last value is again higher. We see that the third value is higher, and then we see that, let's try to find exactly, and then we move one date in the future. We see that the same value, which now is the second value of the window, is higher, and then the next date we see again that that value is higher. Therefore, we see that 18.5 is for 3 days is the highest value. So you get the idea here. Instead of maximum, we can have minimum, we can have the average, mean, I think, yes, or we can have even the standard deviation. So we can have as many statistics as we want. However, what we are asked in the project is to return the high and the low. So we will use the minimum and the maximum, and we're going to return 2 values. Okay, that was the first task. Let's go to the second task. We have a data frame, and which can be the close value of a stock, like what we have here. And we are asked to compute the long and short signals. What does this mean? What it requires here to do is that we want, when our price for a particular date is lower than the close price, or higher, it is higher than the close. Let's go from the top. We have our close, and we are defining 2 thresholds, 2 values. Okay, high and low. So when our close price, high and low are fixed values. When the close price is lower than the low, it means that we want to return -1. When our close price is higher than the high, we return 1. And any value between low and high, we will return 0. Obviously, our price cannot be, let's say, higher than high and lower than low at the same time. Okay. Obviously, there should be a condition here that look back high is higher than look back low. So we need to return that. Let's do something simplified. What I have done here, I'm not using, I'm using just arbitrary values, fixed values that I have defined. Here we have those values are parameters in the project. Okay, but in order, for the sake of simplicity and just for demonstration, I'm using the values of 18.2 for the high and 18 for the low. So when we do that expression, a low close higher than 18.2, when we don't include the second part, we get the Boolean return. However, we can return that as integer, and this is what we get. Then we do that for the when the close price is, let's say, lower than 18. So in this case, we are getting 1, so true when this happens. However, because from our description we want this to be negative, we just add a negative sign at the front as a prefix. So as you can see here, this is what we get. Now, if we want to combine those, because we say that a signal cannot be at the same time higher than high and lower than low, we can just add those two signals and we get the combined signal that it is, the combined trading signal that is required by the task. So there are also some values. Let's see the last value, which is 18.13, which is between those two thresholds. Therefore, here we are returning 0. Essentially, it doesn't change at all from the beginning. So let's say now, let's do a trick. Let's say that we're having a signal, a trading signal like that. Is it possible for us to decompose this into our components? Actually, it is. So for example, to get all the ones, is it possible? Yes. So we say when trade is larger than 0, we're using this syntax in the pandas, trade where trade larger than 0, otherwise return 0. What it says is that return the value when this value is larger than 0, or return 0 otherwise. Okay, so all the negative ones becomes zeros. This is just an extra hint if you need it. So that was the other part. Let's go on to filter signals. When you finish this part and it passes the test, then you will see that we need to filter the signals, meaning that when we have many ones or negative ones in a row, we don't want that. We want to return, if we have, let's say, 3 ones in series, we want just the first one. And this is used because we don't want to overtrade the same signal. So this is explained here. Task, what this part of the project requires is that when we have our signal that we have found here, we essentially want to apply a filter function, which luckily for us, it is already defined. So we don't need to define that ourselves. And what we do is, let's have an example here, is to apply a function. Here I'm applying a function that doesn't make much sense, but just for the sake of demonstration. So I'm defining this function times 100, which returns the value times 100, obviously. So in order to apply that to our data frame, we use the syntax apply and then lambda x, which is times 100 x. Lambda is used for when we want to use functions without naming them, and it is applied. It is working very well with pandas using the apply syntax. So this is something similar that you need to do in this part. However, not with my silly function, but with some more useful function. Okay, so let's move on. What is required further is get look ahead prices. This one, when we read here, it requires us to get the prices ahead of in time. So this is something that we have already seen in previous projects. We need essentially to shift, this is the keyword, to shift our data frame as many days in the future, right? Not in the past here, but in the future. So this one is relatively straightforward, as it is the next part where it requires from us to get the returns. So now we have today's returns. We have calculated from this part here, the returns in the future, which we already know because we use the historic data. And then, we know the prices of today, the prices of the future, and we want to calculate the return. And actually, we know how to calculate the log return, right? It is the log of the ratio of the two values. So this should be familiar from earlier, from project one. And now we want to find the signal return. So this one is slightly more complicated, but not too much. We have the return, we have two data frames. One, it is our signal, which is 1, -1, or 0. When 1, it is we are buying. -1 is that we are shorting, we are selling. And the 0, we are not trading. Therefore, and we know the returns for each state. Therefore, when the signal is 0, regardless the returns, we are not making any profit. This is what we need to see at the end. However, when we trade, when we buy and the returns are high, we're making profit. When we sell and the returns it's negative, because we are multiplying two negative numbers, we get again a profit. And if we are buying and the return is negative, then we are losing. So this gives us a hint. However, we need to find that for each day. Okay, so we sort of have to do a particular operation between the two data frames. So let's go further on. When this is all written and done in the code, then the project requires from us to plot the histogram of the return values. And when we do that, we will see that visually, we will see that there can be some outliers. We have to justify that after seeing the graph. However, our eyes are helpful to get some intuition, but we need to solidify what we see with math in order for this to be accurate and acceptable. Therefore, we are doing what is called the Kolmogorov-Smirnov test. And what this test does is that we are using our data frame, and this signal essentially it's creating this function, and this test is getting the histogram, and it calculates some values that the k value that we will interpret afterwards whether according to those values we have or we do not have outliers. In order to do that, I'm attaching here a particular link. Hopefully this will work. Not yet. Okay, you need to you will have access to that, so let's connect. Okay, this one I suggest that you read it because it gives you a good idea how to implement this function. So when this is done, two values will be returned, ks values and p values for each stock, because here we will use some stocks. Okay, And here, okay, we return k values and p values. And at the end, in order to find the outliers, what we are asked to do is that there will be some symbols, some stocks essentially, that pass the null hypothesis. So we will define the p threshold value and the ks threshold value. And the symbols that have value less than p value threshold and the symbols that have value above ks threshold, they will be our outliers. Attention here, we want, there can be stocks, signals or symbols that can satisfy one of the two conditions. Those stocks, they will not be outliers. We want outliers will be the ones that satisfy both. And from its criterion, we get one set of symbols for the first one set of the other for the other one. And we want to find essentially the intersection of this set, okay? So let's see this link here, which is giving us what we're essentially talking about. So we have two data frames or arrays in this case. Oh, sorry, sets. So sets are immutable objects. And the union, intersection, difference, and symmetric difference. So we are interested in a particular of these actions, of these operations that you will need to do in order to pass this test. And when this is done, then you will be in a very good shape to deliver this project and certainly to pass and continue with your learning path. So that is the webinar for this week. I walk through the project and some tips and tricks. I'm sure for those who haven't delivered yet, it is a good opportunity to do so and get closer to your graduation. So thank you very much for watching this, and we will speak again next week for the next webinar. So thank you for now, and keep learning. Bye.